All right, welcome back, AP Stat students. I'm doing okay. I'm alive. So let's talk about the last lesson of the unit, which is going to be talking about really just connecting all the things that we learned together in this unit. And also know that you have a test when I come back from school or when I come back from my vacation. So let's get started. So the context of this question is pretty much ACT scores from Audrey Kell High School are normal distributed with a mean of 26 and a standard deviation of 3. So that's a population distribution. So ACT scores of Providence High School are skewed to the right with a mean of 25 and a standard deviation of 5. So I'm just going to highlight that the mean and standard deviation of these things in yellow is according to AKHS, and the mean of 25 and a standard deviation of 5 is regarding to Providence. So I would like for you to try filling out this table, but when we read the context of this, of number one, we see that we randomly select 25 students from AKHS, and we take a sample of 30. So use the information given to describe the sample distribution of the average ACT scores of the two samples. So I'm going to give you a little hint here. When you assume something, you're going to be using the central limit theorem that we learned from last lesson online. So I'm going to give you some time to try that yourself. I'll pause the video and then just whenever you're done filling out this table, unpause it in 5, 4, 3, 2, 1. Okay, so we came back and we can see that the shapes of both high schools is approximately normal, but for different reasons. So for AKHS, we learned that if the population size is approximately normal, if you take a sampling distribution of them, you can also assume that it's the same shape. But for Providence, we also said that it's approximately normal, but for a different reason, and that's because of the central limit theorem, because our sample size is greater than 25. So that means that the population of the mean of the populations are equal to the sample distribution's mean. So that's why I labeled this mu of A because of wrong color. Mu of A, which is this of my AKHS, and the mu of P, which is PHS, which I labeled it, is 25. Last but not least, I used the standard deviation equation. Remember that the standard deviation equation is standard deviation of the population divided by the sample size that we're using. So I used the square root of 25 for our first sample, and I used the square root of 30 for my second. So suppose that we took a sample of 25 from AKHS, and I use a sample of 30 for PHS. So we need to find the differences of the sample distribution. So describe the sampling distribution of the differences of the ACT scores. So we're going to be doing AKHS minus PHS. So the mean is pretty easy, right? Because it's 26 subtracted by 25, and that's 1. And really what I did was the mu of A subtracted by P, which is, this equation. The standard deviation is a little spicy. And the reason why is because, as you learned throughout the year, you can't just do simple arithmetic on standard deviation because of the idea of we're going to get an imaginary number. So the way that I like to think of it is with this equation right here, which is a standard deviation. The standard deviation of A minus P, in context, is going to be the square root of the standard deviation of the population of AKHS, and divided by the sample size, square rooted. Yeah, I'm going to square this plus the standard deviation of the population of the second, this should be an A, and this should be a P, divided by the sample size of P, this should be A right here, squared. So you see how essentially we're taking the absolute value of these things, as you learned in in Algebra 2. That's why Algebra 2, I'm going to keep saying it over and over again, is a prerequisite of this class, because you need to understand that we have to do some arithmetic algebraically. So if I simplify this, really, I could write it a little bit nicer. It's like standard deviation of the population squared divided by n plus the standard deviation squared divided by n as well. But these are in context of A and P. And the reason why I can do that is because if I distribute these squares into the following, the square root just disappears in the denominator. So it just looks a little aesthetically nicer. I'm going to do this for us right here. It's going to be the square root of 0.6 squared plus 0.91 squared. And of course, I'm adding them first, and then I'm going to take the square root of them. The standard deviation of this is going to be 1.09. So we've seen some very similar, like, we've seen a very similar equation in different contexts. So just know that, like, standard deviation, you just can't flat out add them because of the rules of imaginary numbers. It doesn't work based off of our context. And then our shape is because it's going to be actually normal again, and that's because both sampling distributions are approximately normal. So of course you have to know that both of them are normal for you to assume the differences of your parameters are going to be normal as well. And my family's starting to harass me right now. Number 3, calculate the probability of random sample of 25 kids have a higher mean than the random sample of 30 kids from Providence. So what they're asking us really is a normal distribution question. So we're going to be finding a z-score eventually. But when I draw this, of course, this is going to be my mean. Why is my thing diagonal? Whatever. Your paper will be better because I'm drawing on a drawing pad on this children's table. So it's going to be n, and it's going to be 1, 1.09. This is what we found from part number 2. And they're asking us the higher mean. So when is it going to be whenever they score higher? So if this is 1, for AKHS people to score higher, they need to be talking about or finding 0, because we're talking about differences. So we're doing AKHS minus PHS. So if my sample was a negative number, then of course AKHS would be scoring lower than the PHS people. So this has to be 0 right here, and we're going to try to find the area of all of this. So how do we do that? We use the context of chapter 1, which is going to be x minus mu divided by standard deviation, which we found. Well, we found all of these right here. This is going to be 0 minus 1 divided by 1.09. That's why it's important for you to label your parameters so that you can use a z-score. This is going to end up becoming negative 0.92. And then we're going to use table A. And last but not least, we're going to do 1 minus 0.1788. That says 7. Which ends up being 0.8212. And that's about an 82.12% chance that AKHS students are going to score higher than PHS. And I would say that would make sense because my context right here, we have AKHS has first a higher mean, two they have a lower standard deviation, and three AKHS has a normal distribution of their population, but the population of Providence has a skew to the right. So, like, based off the context, I would say this makes a lot of sense. So, let's conclude the chapter with a learning target, or I guess we're going to do our learning targets, or whatever. So, we have two. So, learning target number one, sampling distribution of like a sample minus another sample distribution. So we're going to do the SOCs here: shape, center, variability. So the shape, you're going to check if both distributions have the same shape. If the shapes don't end up matching, you can safely assume that you did something wrong in the AP exam. The way that we checked for our shapes in this context was, the first one was the population shape, and the second one was using the central limit theorem, which was n is greater than or equal to 25. The center, we just did the population average. So x bar 1 minus x bar 2, and this ended up becoming really just mu 1 subtracted by mu 2. Mu 2. Variability, we learned a new equation again, I guess. Kind of new, kind of not. So the standard deviation of the population divided by the square root of, not the square root, of n, but just square the numerator. Plus the standard deviation. Oh, this is not p. This is 1. This is 2. Divided by n squared. And I guess the last learning target, once again, it is the normal distribution once again. We always try to connect normal distribution into all of our lessons because we haven't learned a lot about how to calculate probability besides using normal distribution, unless if it's a given. So when I draw my normal distribution, my n is going to be like the mu 1 subtracted by mu 2, comma, the standard deviation equation. I'm not going to write it all. You can write it like this right here. This equation is pretty much this big equation for variance. And once again, z-score is equal to x minus mu, so divided by standard deviation. Nice. I guess I'll help you out with this learning target right here. So, is it more expensive to live in California or Florida? Most monthly costs of living for California are approximately normal with blah and blah. Florida is also approximately normal with 8,500 and a standard deviation of 2,700. So based off the context already, I would probably live in Florida if I'm talking about only money. Suppose we did SRS on 16 people in California and 9 people in Florida. Calculate the sample mean living costs, like the differences of x bar of C and x bar of F. So what is the shape of the distribution of California minus Florida if you take the averages of them? I'm going to skip that one. Pretty easy. Find the mean and standard deviation of the following. So just know that we use our equations here. Mu 1 subtracted by mu 2. And of course, the other equation for standard deviation is going to be standard deviation squared divided by n plus the standard deviation squared of the second divided by the population, the sample size of the second. So you should get two things. And last but not least, for number 3, calculate the probability that the average monthly cost of living expenses for the 16 random Californians is less than the average. So if I draw my normal distribution here, come on, I can't draw straight. And if this is my mean that you are going to find here, I'll tell you, this is going to be 2,300. This is pretty easy. They're asking us for my x bar to be 0. But they're asking me, like, what happens if it's less than? So I need to be finding the area to the left of my of my sample. So when you do your z-score, you need to take in consideration that you do need to find your standard deviation, but it's going to be 0 minus 2,300 divided by your standard deviation that you find from part boy. And then, of course, you're going to do table A. Then you're going to do, you're going to do table A, and then you're going to actually just find the area. And that's going to be your answer here. I'll give you a hint. It's going to be point blank 8. Oh, sorry. That's not true. Here we go. 3 decimal points, and 8 is going to be the last decimal point that you find. All right, well, I'll see you guys back in class for our test. Assume that's going to not be that hard because this lesson is actually not one of the harder ones. So we're just trying to breeze through this because we're running out of time for our preparation for the AP test. So hopefully you guys are okay, and I'll see you guys next time. See ya.